we go. Polynomials is our topic for today. Polynomials. This is algebra. Polynomials refers to vocabulary in algebra. Okay? So in algebra we have, this is review, we have expressions and equations. Right? An expression is a series of things added together. 3x plus 2 is an expression. An equation is two expressions that are equal to each other. So if I said 3x plus 2 equals 20, this is now an equation. Right? So equation has to have the equal sign. So obviously these are really general terms, right? An expression could be anything that fits on one side of an equation. So I could have an expression that's like 3x plus 5 over parentheses 1/2 x minus 4 to the x.2 power. I don't even think you can do that in math, but anyway, there's a lot of different possibilities for expressions. And so we can now, I'm going to give you some terms today that let you name types of expressions. Okay? So the idea there, I know you probably didn't write all that down, but the idea was that we have expressions and equations. Those are really general terms. An expression can be pretty much anything that you write without an equal sign. An equation is pretty much anything that you can write with an equal sign. So how do we name them more specifically? Well, we have this thing in math called a monomial. A monomial is an expression with one term. X. What's a monomial? 7 monomials. Then we have binomials. Binomials. Anyone want to guess how many terms? 2. X plus 3. This is a binomial. 5x minus 6. That's a binomial of 2 terms. We have trinomials. How many terms do you think trinomials have? 3. So 2x squared plus x minus 6. This is a trinomial. And you notice, now I have this x squared term. Most trinomials that you see in algebra are going to have an x squared. Why is this not a trinomial? 2x plus 4x plus 3. Yeah, because this is really one term, right? 2x plus 4x is just 6x plus 3. Yeah, but I can't add 2x squared plus x. Right? There's no way to add the x squared to the x. There's no way to combine this term with this term. And that's actually the important thing that we're going to talk about today. So, a trinomial has 3 terms. Generally, one of the terms is going to be x squared. And then after that, we just call them polynomials. Polynomials just means a bunch of terms, right? So maybe I have 3 minus 7x squared plus 11x minus 137. Right, it's a polynomial. There's a bunch of terms. And honestly, you're not going to see a lot of these in Algebra 1. Okay. Poly means many.
Oh, so you're like
so many terms, right? Tri means 3. So 3 terms. Bi means 2. Mono means 1.
So you just combine all the tri, and monomial all together. That's pretty much polynomials.
Polynomials are bigger than trinomials, right? There's more terms than a trinomial. So it has 4 terms, or 5 terms, or 6 terms, or 7 terms, or 8 terms, etc.
Okay.
Good question. Now, I want to be clear, right? Anything that has 3 terms is a trinomial. But the most common way that you'll see them in Algebra 1 is like this. X squared, x, and a constant. That is the most common form of trinomials that we will see in Algebra 1. Okay. All right. So, I'm going to start erasing. The next thing we're going to talk about is how do we add these things together? How do we combine them?
Don't do it.
You're not there yet? Okay. So let's say I had this polynomial, x squared plus 2x plus 3. And I wanted to add it to this trinomial. 2x squared plus 3x plus 7. How do I do that? The first thing to recognize in this, so let me give this a title, adding. Adding polynomials. With addition, these parentheses aren't important. Even though you'll often see them in problems like this, they're not important.
Oh, dude.
So the first thing that I'm going to do is I'm just going to rewrite this. X squared plus 2x plus 3. And what I like to do is I'm going to write the second one underneath it. But notice how I do it. The 2x squared lines up with the x squared because these are like terms. The 3x lines up with the 2x because those are like terms, and the 7 lines up with the 3. Remember, a like term that means that it has the same variables with the same exponents. So I'm lining up my like terms. 3x and x squared are not like terms because they have the same variable, x, but it's to a different exponent. Now all I do is I combine my like terms. So x squared plus 2x squared is just 3x squared. 2x plus 3x is just 5x. And 3 plus 7 is just 10. So now I have my answer. And that's it.
Oh, really?
That's all there is to this. Yeah, we're just, so you've actually done this before, it just hasn't looked like this. Because you guys have done combining like terms, but we've never done it with more complex polynomials, and we've never used this terminology. So it's just kind of like the next level, extending what you've already done.
This twist says no.
Yeah, this is actually. Okay, hold on.
Yeah, this is fairly simple. So what if we're subtracting?
Yep, there's a twist.
It's not really a twist. Let's say I have 2x squared plus 4x plus 10. And then it says minus x squared plus 3x plus 5. The key thing to remember if we're subtracting this entire polynomial, this entire trinomial, is that the minus applies to everything in the parentheses. What property is that called? the distributive property. I'm distributing my minus sign. And so when I rewrite this, I'm going to write negative x squared underneath my 2x squared. I'm going to write negative 3x underneath my 4x. And I'm going to write negative 5 underneath my 10. So now I have 2x squared minus x squared. That just gives me x squared. Because 2 minus 1 is 1. 4x minus 3x, that's just a positive x. And a 10 minus a 5, which is a positive 5. So now I'm just subtracting
So you just turn
each
it
term.
to
Yeah, I turn each one of these to a negative. Right? Negative x squared, negative 3x, and negative 5. What would have happened if this had been already a negative? What would this be? It would become a positive, right? And then this would become 10 plus 5 would be
15.
plus 15, right? So a negative times a negative gives me a positive. That's all there is to it.
So it's the same way.
Yeah. Same thing. And you'll see other examples of this. They can get a little bit more complicated, but it's the same process. Okay, let's go on to practice.